Good evening, class. We are looking at College Algebra, Chapter 3, Functions, Section 3.3, Rates of Change and Behavior of Graphs. We covered Sections 3.1, Functions and Function Notation, Section 3.2, Domain and Range, and now 3.3, Rates of Change and Behavior of Graphs. The objectives are to find the average rate of change of a function, use a graph to determine where the function is increasing, decreasing, or constant. Use a graph to locate local maxima, local minima, absolute maxima, and absolute minima. Recall functions and function notations, dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. Relation, a set of ordered pairs. Domain, the set of all input values known as x values, independent variable for a relation. Range, the set of all output values known as y values, dependent variable for a relation. For example, if we have a graph, if we could see which portion along the x-axis is covering, that would be the domain for this graph. And the portion that it covers along the y-axis is the range for that. A function is defined as a function is a relation in which each element in the domain corresponds to exactly one element in the range. Reminding you of the difference quotient and its definition, f of x plus h minus f of x over h, where h can be zero, can't be zero. Use a vertical line test for a function. If a vertical line can be drawn so that it intersects the graph at more than one point, then the graph does not represent the function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. Also, we have a one-to-one function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. With that goes the horizontal line test, also known as HLT, if a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. So in short, vertical line test versus horizontal line test. Function, the x coordinates can't repeat a one-to-one function. Neither the x nor the y can repeat. Here's the library of functions. F of x is b. That is a constant. So f of x equals b. It's a horizontal line with a y-intercept of 0b, domain of negative to positive infinity, and range is b. The identity function f of x equals x. That is a linear function with domain and range being all real numbers. For f of x equals x squared, the domain is all real numbers. The range starts from here and goes up, 0 to infinity. For f of x or y equals x cubed, known as a cube function, domain and range are all real numbers. For the square root function, the x covers the positive side of the x axis and the y does the same thing. So in both cases, 0 to infinity would be the domain and range. In the case of a cube, it covers everything, and therefore domain and range are all real numbers from negative to positive infinity. In the case of a reciprocal function, f of x equals 1 over x. This is what it looks like. It covers all the x-axis except 0, all the y-axis except 0. So the way we write that, domain is from negative infinity to 0, union is 0, union 0 to infinity, and the range is the same, minus infinity to 0, union 0 to infinity. Now, let's look at 3.3, rates of change and behavior of graphs. The difference quotient as the definition, delta y over delta x, is rise over run, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. This is called the average rate of change of y with respect to x over the interval of x of 1 to x of 2, and can be interpreted as the slope of a secant line. If you look at this curve, if you pick any 2 points and connect the 2 points, it gives rise to a blue line known as a secant line. Delta x, or x of 2 minus x of 1, represents the run. Delta y, or f of x of 2 minus f of x of 1, represents the rise. Therefore, depends on how we do the writing here, we are going to have the following. M is rise over run. If you go with this 2 points, the way they are given, f of x of 2 minus f of x of 1 over x of 2 minus x of 1. If you call this x, and f of x becomes f of x minus f of a over x minus a. And if you call this a and this distance h, this now is a plus h. This becomes a plus h, and this becomes f of a plus h. So f of a plus h minus f of a plus h minus a, which gives us h. So we want to find the average rate of change of a function, which in short, it represents the slope given 2 points. So delta y over delta x is f of b minus f of a. We want to find the average rate of this function, f of x equals 3x squared from 1 to 3. So in short, we want f of 3 minus f of 1 over 3 minus 1. So we're going to plug in 3, we plug in 1, obviously the denominator is 2. When we plug in 3, 3 times 3 squared minus 3 times 1 squared, this is 9. So you get 27 minus 3, 24 over 2, and that is 12. From 1 to 5, well, we've calculated f of 1. Let's calculate f of 5. 3 times 5 squared. $75 minus 372 divided by 4, and that gives you 18. For 7, we do the same thing, f of 7 minus f of 1 over 7 minus 1, and we plug it in. Use a different color. 7 squared, 49. 3 times that, 147. Minus 3 is 144 divided by 6, gives us 24. And if we were to plot, we would find those points: 1, 3, 327, 575, 7, 147. And that would be finding the average rate of change from 2. We need 2 points. So given y equals f of x and point P with coordinates a and f of a, the slope of a secant line is simply rise over run, everybody. So when we look at this one, we say this has coordinates a, and therefore f of a. This one has coordinates x and f of x, so would be f of x minus f of a over x minus a. So if you have any 2 points, you connect the dots, you create this secant line. This is the run, in this case x minus c. If you call this c, this is the rise, f of x minus c, and this line connecting 2 points on the curve is called the secant line. So we call this CF of C. If we call this AF of A, then B minus A is the run, F of B minus F of A is the rise, and it gives rise to this equation, F of B minus F of A over B minus A. So if we go with this format, where the first point we say A and F of A, then we have this distance, this run as H. So this is A plus H. So this is F of A plus H minus F of A. The rise is F of A plus H minus F of A. The run is just H. The point being, they all mean the same thing. Normally we use this one to call it a DQ, the difference quotient. Normally, but all of them are really DQ in essence. The difference quotient. In the previous example where y or f of x was given as 3x squared, we calculated this average rate of change for various pairs. Okay, for example, for these two pairs is 24. For these two pairs is 18. For these two pairs, the average rate of change is 12. So it depends. So it's not fixed. Why it's not fixed? Because it's a curve. But if it was a line, it wouldn't make any difference where you pick the pairs. Given g of x equals 3x squared plus 2x minus 1, we want to find the average rate of change of g from the g function from -2 to 1. All right. Delta y over delta x is f of b minus f of a over b minus a. So let's plug in the second point 1 minus the first point -2, and the bottom is 1 minus -2. So this is A, this is B class, if you will, in essence. This is A, this is B. Just plug it. That's all you have to do. So what we are dealing with here is 1, so that times 3 is 3 and 2, 5 minus 1. This becomes a 4. This is positive 4 times 3, 12 minus 4 is 8 minus 1 is 7. So this is 4, this is 7, 4 minus 7, which makes it -3 over 3 equals -1. Find the equation of a secant line. That means we are going to use the point slope y minus y1 equals m times x minus x of 1 with a pair 1, 4. y1, 4, you have to get one of those pairs. If you recall, if you look at this one, you can use either 1, 4 or -2, 7. Let me make sure everybody understands what's happening. Either 1, 4, that's a pair, right? Or -2, 7. Either way is fine. So y minus y1. So y minus 4 equals m negative 1, x minus x of 1. That means x minus 1. You distribute, you get minus x plus 1. You move the 4. You get y minus x. Y equals minus x plus 5. Notice if you plug in negative 2, you do get 7. So it actually checks. Graph the function g of x and the secant line, and it looks like that. Now we are going to discuss quadratic functions further. As far as the line is concerned, we have really two pairs, or we can, use the fact that, for example, 0, 5 is the y-intercept, and I hope you see that 5, 0 is the x-intercept. So the line is easy, and we can graph the parabola with more details later on. But what I wanted to show you quickly, how it's done with a graphing calculator in case. So we want to look at the third part, graph g of x equals 3x squared plus 2x minus 1, and the secant line y equals minus x plus 5. I want to show you the information that it's already posted under the last module in Canvas. So TI calculator, how to graph. Enter equation into y equals area. Be sure the plots at the top of windows are turned off. When the equal sign is highlighted, the graph will be displayed. There's some more explanation here. The idea is that you're using a graphing calculator. One of them, y1, you put the first function, y2, you put the second function. As far as the note is concerned, the symbol to the far left of the equation indicates the style of the graph. You can read about this. There is more information here. And there is this information about the viewing windows if in case you can't see the entire graph, because normally it's a 10 by 10 window. So the most common choice is number 6, the Z standard, which gives a negative 10 to 10 by negative 10 to 10 window as far as the window is concerned, okay? So you graph it, it will look like this. When you hit the graph. So I want to show you, if you look at this graphing calculator, after you input that information into Y, in other words, if you click this one and write that, so Y, and you write the information, graph, and it gives you the graph. How to find the intersection? Press the calculator. That means second and trace. Here's the second, here's the trace. You click those. And then you choose intersect, which is number 5. So when you hit those, it shows up. You go down to number 5 and you click, either you click number 5 or you go down and you press enter when you're at top of number 5. Now for the first curve, hit enter. So it says first curve, just there's a question mark, just click enter. For the second curve, so enter here, enter here. Then for the guess arrow to the intersection, it's asking to guess that since there are two intersections, You are moving towards one of them. In this case, I went up towards this one. See the pair that it shows, it's where it's at. Now that I hit enter, it takes me precisely to the location of intersection. It gives me the answer, -2 and 7. I repeat that and I move it towards the other one. As I move it, it says first curve, enter. It takes you to the next intersection and it gives you 1, 4. And of course, it's a more precise graph, a bigger graph to understand. So that's how the graphing calculator will return the answer for you. So getting familiar with graphing calculators as well. Example 3, given f of x equals -2x plus 4x minus 3, and of course we know delta y over delta x is f of b minus f of a over b minus a. Find the average rate of change of f from -2 to 1. Let's plug in. We are going to plug in this is A, this is B. We are going to plug in the second point. Although, if you put them in a different order, as long as you follow it at the bottom, it works the same way. So you're gonna plug in 1, and then you're gonna plug in -2. That's for the numerator. At the bottom, 1 minus -2. The bottom is clearly 3. So what happens here? This is 1 times -2 makes it -2. Plus 4 makes it +2 minus 3. They add up to -1. And this parentheses, -2 squared is +4 times -2, -8. With -8, -16. With -3 is -19. So -1 plus 19 gives us 18 over 3 equals 6. When I find the equation of a secant line, the pair is 1, -1. 1, -1. Or you could use the second pair, -2, -19. So y minus -1 equals m 6 times x minus 1. So this gives us 6x minus 6. This gives us y plus 1. We are moving this one and we get y equals 6x minus 7. This one, I want to make sure that you can read this. This is -2. Okay. So 6 times -2 to check, -12. -7 gives you -19. To graph this, you can use a calculator. You can do it by hand. The line is very easy to graph. And you graph the parabola. We'll give you more details later on. And you can use a graphing calculator even for this case, just to speed up the process. Rates of change and behavior of graphs. And we know the average rate of change of a function is defined as rise over run. Okay, pick up 2 pairs, and calculate f of b minus f of a over b minus a. Let's add things to it. Even function, f of minus x equals f of x, it's symmetric with respect to the y-axis. Odd function, f of minus x equals minus f of x, and it's symmetric with respect to the origin. For an even function, for every point x comma y on the graph, the point minus x comma y is also on the graph. For an odd function, for every point x and y on the graph, the point minus x minus y is also on the graph. A function f is increasing on an open interval I if for any choice of x of 1 and x of 2 in I with x of 1 less than x of 2, we have f of x of 1 less than f of x of 2. A function f is decreasing on an open interval I if for any choice of x of 1 and x of 2 in I, where with x of 1 less than x of 2, we have f of x of 1 larger than f of x of 2. And finally, a function f is constant on an interval I if for all choices of x in the interval I, the values f of x are equal. The shorthand version for the increasing and decreasing is as follows, class. In short, this says when x gets larger, so does y. For the decreasing, when x gets larger, y gets smaller. That's it. Determine even and odd functions from a graph. We are repeating the definition. We are looking at this example where three graphs are given. As you can see, this one is an even function because it is symmetric with respect to the y-axis. With respect to, sometimes we just write WRT, okay? Stands for with respect to. In this case, it's neither even nor odd because no symmetry with respect to the y-axis or the origin can be seen. And this one, there seems to be symmetry with respect to the origin, therefore it's an odd function because it is symmetric with respect to the origin, as we can see it from the graph. We're going to continue with this concept, identify even and odd functions from an equation where f of x is given as x cubed plus 5x, and we are reminding everybody even function means f of minus x equals f of x, odd function f of minus x equals minus f of x. All you have to do, evaluate f of minus x. As we do that, we replace the x with minus x here and there, and this becomes minus x cubed. This becomes minus 5x. We can factor the negative sign out, and it's equal to minus f of x, which makes it an odd function. So it's an odd function, therefore symmetric with respect to WRT, with respect to the origin. B, g of x is 2x squared minus 3. We are going to replace the x with negative x. Negative x to the power of 2 is the same as x squared. So this is 2x squared minus 3, which is identical to the original function g of x. And that's the proof this is an even function and therefore symmetric with respect to the y-axis. H of x is minus 4x cubed plus 1. We are going to replace the x with negative 1. This becomes minus x cubed times minus 4 becomes positive 4x cubed. This is not equal to h of x. This is not equal to negative f of x. So therefore, it's neither nor. Since the resulting function does not equal h of x nor minus h of x, this function is neither even nor odd. Let's look at this one. Let's plug in negative x. As you know, the absolute value of x and minus x are the same. So this is the same whether I put the negative in or out makes no difference because it's an absolute value. And therefore, because it's identical, it makes it an even function. So it makes it symmetric with respect to the y-axis. Use a graph to determine whether a function is increasing, decreasing, or constant. So reminding you of the definition we gave. So increasing looks like that. Decreasing looks like this. Constant looks like this. A function is increasing on an open interval in an interval of I for any choice of x sub 1 and x sub 2. X sub 1 is less than x sub 2. We have f of x sub 1 less than f of x sub 2. So we are elaborating on that increasing, decreasing function. Decreasing is the other way around, as we mentioned it, and a constant says the values for the function, they remain the same. So the functional values are the same. So increasing, decreasing, constant. So although it's a curve, if you, in your mind, if you assume it's a line with a positive slope, increasing. This is a line with a negative slope, and of course, this is a horizontal line with a zero slope. So having said that, given this graph, where is the function increasing, decreasing, constant? So clearly you can see it's increasing here. Again, in your mind, you can even imagine it's a line with a positive slope. So it's from here to here. So from -4 to 0. We don't include the endpoints, okay? It's an open interval. The function is decreasing. It's decreasing here, and it's decreasing here. Therefore, it's decreasing from here to here, which makes it from -6 to -4, union from 1 to 3, 3 to 6. So from -6 to -4 along the x-axis, from 3 to 6 along the x-axis. So -6, -4, union 3 to 6. Where is the function constant? Right here, up here. So it's from here to here along the x-axis, from 0 to 3. Use a graph to locate local maxima and local minima. Maxima is the plural of maximum. Minima is the plural of minimum. So a function f has a local maximum at C if there is an open interval I containing C, so that for all x not equal to C in the interval, f of x is less than or equal to f of C, we call f of C a local maximum of f. So like this one is a local minimum, like this one is a local maximum. So this is a local max, looking like almost, you can think of it as an n, a portion of n. A function f has a local minimum at C if there is an open interval I containing C, so that for all x not equal to C in the interval, f of x is greater than or equal to f of C. We call f of C a local minimum of a function, looking like almost a u, if you will, a portion of a u. Local max, local min. So here's the formal definition for maximum or minimum points on a curve. Local, or also known as relative extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of a to b in the domain if f of c is less than or equal to f of x for all x values in the open interval. So if you look at this one, this is considered a local mean. By the way, this is considered a local max. A local maximum is the maximum value within some open interval. Local maximum occurs at the point C in an open interval a to b in the domain if f of c is larger than f of x for all x values in the open interval. So as I mentioned, this is a local max. Now, what about absolute, also known as global extreme values or extrema? They are either maximum or minimum points on a curve. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all, that's the key, for all x values in the domain. So when we look at this point, we notice this is not only a local, also an absolute minimum. Okay, I will explain that after I go through the last one. Absolute maximum occurs at the point C if f of c is larger than f of x for all x values in the domain. So this one is an absolute maximum. So let's just recap the whole thing. This is a local mean. Why is it local? There are other points having a smaller y coordinate. This is a local max. Why is it local? There are other points having a larger y coordinate, the same thing as it was explained here. This is a local mean. This is a local max. This one is a local mean. It is also an absolute mean because there is no other point having a y coordinate smaller than that. Local max, local mean, local max, and this local max is also an absolute max because no other point has a larger y coordinate. All right, we want to use a graph to locate local extrema, list the intervals on which f is increasing, decreasing, and so forth. Let's start with the increasing. So decreasing, increasing, decreasing, increasing. So as I mentioned, imagine it's a line and you can figure it out. So if it's increasing here from here to here, this is -1, this is 1. So from -1 to 1, union 3 to, because it's an arrow, that means it just keeps on going infinite. And decreasing is here, again, because of arrow, that means -infinity to -1, union this part from 1 to 3. At what number or numbers, if any, does f have a local maxima? What are local maxima? So the local maximum occurs at this point at x equals 1, and the value is equal to 2. The way we write it is important. You can say if they're asking at what point precisely, and they just want the x coordinate is x equals 1, but normally they want the pair, you're going to say maximum is equal to 2. At what point? At the pair 1, 2. Depends how they ask you. They may want the x, they may want both coordinates, but if they ask you, look at this one. What are local maxima? They are asking for the y value. And the same question for local maxima. At what numbers, if any, does f have a local minima? What are local maxima? So right here and right here, we have the local mean. This one, local minimum. This one, local minimum. So local minimum takes place at x equals -1 and at x equals 3. And the way we write it, local minimum is equal to 1 at this pair -1, 1. Local, this is local, also absolute. Why is it local? because if it's peaks and valley, it's a local. If it's in the interior part of the domain, so it's local. Why is it absolute? Because there's no other point having a smaller y coordinate. So it happens at this pair, which has a coordinates 3 comma 0, and the y coordinate is 0. So local and absolute minimum equals 0, equals 0. Minimum. Okay. So again, I want to make sure we understand the value of a local extremum or absolute extremum is the value of its y coordinate. Okay, everybody? The value of the y coordinate. All right, let's look at this case. Find the absolute maximum and the absolute minimum if they exist. This is a local max as well as absolute max because there's no other point having a larger y coordinate. So absolute max equals to the y coordinate, which is 6 at the pair 3 comma 6. Now, this is a local mean. Why is it local? Because there are points having a smaller y coordinate. This one is not local because and the points cannot be local. This is an absolute minimum or nothing. In this case, it's an absolute minimum equals 1 at 0, 1. In this case, absolute max equals 3 at this pair. Absolute minimum, since there is a hole here, there is no absolute minimum. Why is that? Because there's a hole. If there wasn't a hole, it's not a part of the graph. So therefore, we don't have it. This endpoint is nothing. Okay, it's neither local nor absolute. Because first of all, okay, let me just write that the endpoints, the endpoints can't be local extrema. Okay, the endpoints just maybe the absolute. So as it so happened that this was an absolute, whatever, absolute mean or max. If we look at this one, this is the endpoint, and there is no other point having a larger y coordinate. So the absolute max equals 4 at the pair 5 comma 4. Now, this one is nothing. It's not local. It's not absolute nothing. Because the bottom is right here, so the absolute minimum has the y value equals 1, but in the interval of 1 to 2. So the way we write it is absolute minimum equals 1 on the interval of 1 to 2. Find the absolute max and the absolute mean if they exist. So if we look at this one, this continues indefinitely, so there is no absolute max. However, this ends here. This is representative of the location of absolute mean. So absolute mean is equal to the 0, which is the y coordinate at 0, 0. There is no local extrema class. Let's look at this case. This continues indefinitely. So this doesn't have an absolute max. This one has a hole here. If it wasn't a hole, then we would say absolute max equals 4 at 1, 4, because it's a hole. None of them have an absolute max. So max is out. What about minimum? If this wasn't a hole, we would have an absolute mean, but it is, we don't have it. And this one, it just continues indefinitely down, so we don't have absolute max or absolute mean in any of these two cases. Let's discuss the local. This one doesn't have a local extrema either, because the only possibility would be here, and since we have a point there, we have a hole there, it's not part of the graph, therefore we don't have it. What about this one? This could have been the local mean, but it's not because it's a hole. But definitely, this is a local max equals 3 at the pair 4, 3. So local max equals 3 at this pair, no local mean. You really want to remember that later on in calculus, this becomes a huge deal. Find absolute extrema. Well, the graph starts from here and ends here. So here's the extreme value theorem, which is extremely important. If f is a continuous function, this is a continuous function, whose domain is a closed interval of a to b. So it's closed from -2 to 6. So this one, this a to b for this one is -2, 6. Then f has an absolute max and absolute mean on the interval of a to b. Use a graph to locate the absolute max and mean. So what is the extreme value theorem? Again, it's coming up in calculus. If you happen to have a continuous function, which is closed from a to b, for us in this example, the a to b for this is from -2 to +6. We must have an absolute max as well as absolute mean. As you can see, here's the location of absolute max. So absolute max equals what? 5. At what point? 0, 5. We also have an absolute mean. Where is that? Here. Absolute mean equals the y coordinate of this point, which is 0 at 4, 0. This is the way you write it. When you want to answer this question, you want to see how they want you to answer it. Okay? Which of the following are graphs of functions? So let's quickly answer that part. This is not a function. Because it fails the vertical line test. It fails VLT, the vertical line test. And you can see it just like if you look at the y-axis, it crosses it twice. So it's not a function, but this one is a function. Now let's answer the rest. Determine whether the graph is that of a function. If it is, then use the graph to find the following. So this, forget it. Let's find the domain range, everything else for this one. Let's start with the domain. To understand the domain here, you really have to recognize there is a vertical asymptote at 2. So the domain is from 2 to infinity. 2 is not included. That means you put a parentheses. Range. This covers everything along the y-axis. So it's all real numbers from negative to positive infinity. Any intercepts, clearly we have the intercept, x-intercept at 3, 0, and I don't see any y-intercept. So this point with coordinates 3, 0, that's the x-intercept. Y-intercept does not exist. And finally, what about symmetry? Nothing. No symmetry. It's not symmetric with respect to the y-axis, which makes it even. It's not symmetric with respect to the origin, which makes it an odd function. In order for it to be symmetric with respect to the y-axis, we should have a branch here. With respect to the origin, we should have a branch here looking like that. We don't have it. So here's the graph. Where is the function increasing? Where is the function decreasing? I'm reminding you of all of those definitions we've been through a number of times: increasing, decreasing, constant. In short, I'm going to remind you again. Increasing, simply put, x gets larger, so does y. Decreasing, x gets larger, y gets smaller. And one easy way to look at it, increasing, think about a line with a positive slope. So for example, this portion, you think of it as a line with a what? Positive slope. So from here to here, so this portion from here, -3 to here, 0, it's an increasing function, whereas the rest of it, this portion as well as this portion, looks like a line with a negative slope. This portion is continuous indefinitely, okay, class? So from -infinity all the way to -3, and then from 0 to infinity. So it's decreasing from -infinity to -3, union 0 to infinity.